To do a simple linear regression analysis, go to Analyze, Regression, and Linear. This is the same dialog box that you would use for multiple independent variables, but here I have just a single dependent variable and a single independent variable. If you were doing multiple regression, you could put in all sorts of stuff under independent. Leave everything else the same. Under statistics, you can get things like model fit and R-squared change. Model fit is on by default. R-squared change you might want to click on. And for plots, you'll want to do a plot to allow you to look at whether or not the residuals are the same across the whole range. Here, I've brought over on the y-axis the residuals and on the x-axis the predicted. And these are both z-score. I've also checked on the histogram. Save allows you to save all sorts of stuff and estimates from the analysis. That's useful for other analyses in Stats 2, but not for here. And options you can leave as the default as well, because that has things like the missing values. Here, you might change it to replace with the mean. That's okay to do in analyses, because if there's not a systematic reason that data is missing, mean plugging, as it's called, is an effective way to make use of some of that data. Hit OK. And your model will come up here. Here is your variable that you entered. You're only going to have one because we're doing simple linear regression. It gives you your positive affect. Here it gives you R-squared, adjusted R-squared, which is a fudge factor. Since we have a big sample, it's not going to be all that different. And these things over here you'll make use of in Stats 2. Notice that this means that 16% of the variation in positive affect is related to variation in hope pathways. So we can explain 1/6 of what's going on in positive affect if we know someone's hope pathways. The ANOVA table, don't worry about too much. These are your coefficients, the unstandardized ones here. They have their standard error. And you have a standardized one. Remember, this is the same kind of thing as a correlation coefficient. And these are the t-tests to see whether or not the b coefficients are different from 0. And notice that both are significant. You have residual statistics. This gives you mins and max and means of the predicted value, your residual, and your standardized. These are just z-scores of those two. Here we have a histogram of the residuals. Notice they're fairly normally distributed, although it is in some ways leptokurtic because we have this big spike in the middle. And you'll notice that when we plot the residual versus the predicted value, that it actually ends up being okay. Most things are within a regular band. It doesn't spread out like a big triangle. It doesn't go up and down like some sort of curvilinear relationship.